I don't think you're going to like this riddle, but here goes. If yesterday had been Wednesday's tomorrow, and tomorrow is Sunday's yesterday, what day would today be? Maybe I'll wait till the end of the video for that one. Well, here we are in section 5.8. We're really not going to spend a whole lot of time in this section. The main part of this section that I want to cover is the exponential growth and decay models. This is what you're going to be taking with you into AP Calc. Actually, you will be also taking in Newton's law and logistic growth and decay models, but we're just not going to cover that now. I don't like the way the pre-calc book talks about those, so we're just going to save those for calculus. Alright, and so we really just have two objectives today, just finding equations of populations. Basically we have exponential growth and decay, and the main thing that I want to point out here is that in the last section we had the A equals PE to the RT, and that was compound interest, where you deposit money in a bank account and you get interest compounded continuously. Remember Pert shampoo? Well, basically all the problems in section 5.8 follow the same model, and the model that they follow is n equals n sub 0 e to the kt. Alright, so if you look closely at those, you'll see that they're actually the exact same exponential growth formula. And with compound interest, or the money that you deposit into the bank account, is always going to grow. And the only difference with growth and decay problems is that sometimes you start with a population. N sub 0 would be the initial population, and then it would actually decrease in population. So some organisms die out, some cells die out, and we'll talk about that. But just keep in mind that n sub 0 represents the initial amount, or the population. There we go, at time t. Alright, n sub... Oh, I totally blew that, sorry. That is the initial... I don't want to start this video over. The initial population. The n is the population at time t. Okay, so just clarify that. N sub 0 is the initial population. That's a constant. And n equals population at time t. That's going to change depending on time. And t is, instead of it's time, number of days, years, whatever. So let me put, instead of a number there, we'll put time. Okay, it could be years, days, minutes, seconds. It just depends on what the problem calls for. In the last section, t was always in years. And then k is just this constant that basically determines, or basically determines how fast or slowly this population is either going to grow or decay. Okay, so it's just a constant, and we call it usually the growth or decay constant. And you'll see how that works. It's similar to the interest rate. The higher the interest rate, the faster the growth of the money. The higher the K, the faster the growth of the population. So it really is related to the same exact concept that you guys learned back in section 5.7. So let's go ahead and just do a problem here, and we'll show you how it works. We have bacteria growing, and they actually give you the formula here, and normally you don't get a formula. You kind of have to earn it. But you're given the formula, and let me just go ahead and highlight that. N is measured in grams, so you just got to pay attention to little details here. N is measured in grams, T is measured in days, so maybe we highlight that there. Grams, and T is measured in days. How long? Okay, so we're trying to figure out how long something's going to happen. We're going to find T. How long? T equals, I don't know. Will it take the population to reach 150 grams? Okay. So 150, that's our N. And you can see since the K and the N sub 0 were already filled in, it's just a matter of filling in the details in the right order. we want N to be 150, and the initial population was 108.3 bacteria, e to the 0.012 times t, and this is our exponential equation that we need to solve for t, and that would give us how many days it would take the population to reach 150 grams. By the way, this K right here, you'll hopefully start seeing here that K being positive means that we're going to have growth. The numbers are getting bigger. And in some textbooks you'll see a negative sign in front of that, and don't worry about that. Just put a K there and figure out what K is, and everything else will work out just fine. Try to confuse you. I'm here to try to help your lives be a little bit easier, make your lives easier instead of trying to complicate them. Alright, so just like we did last section and a couple sections before that, we're going to divide by 108.3, because if we try to take the log of both sides at this point, then we run into some difficulty. So always, before you take the log, before you change this to log form, just get the e by itself, or e to whatever by itself. Okay, so you'll need a calculator here. And before we use a calculator, let's go ahead and take the natural log of both sides. And you know what? I'm going to go ahead and write one more step. 150 over 108.3 equals, so I can have some room over there, e to the 0.012 times t. So let's be just really careful about where we put our numbers and what we put where. So just be careful. We're going to take the log of both sides, and I still am seeing some of you guys not knowing what to do on this side here. ln of e to something. Okay, basically ln of e to something means the ln and the e are going to cancel out, and you're just going to get the something. Okay, so we get ln of 150 over 108.3 equals 0.012 times t, and then we divide both sides by 0.012, and that's our value for t. Right there. And so just let's go ahead and plug that into the calculator, and we get let's see here, ln 150 divided by 108.3. We're going to divide that ln by 0.012, 27.144. Okay, let's make sure we understand what that means. So this t is about equal to 27.144, and look back, how long, that's t, and in what, days, okay? So 27.144 days, and where is my red? There it is. Okay, there you go. Does that make sense? Well, I guess I don't really have anything to measure that with, so we're just going to have to hope that we did it right. Okay, so did I tell you guys a riddle before this? It's getting late right now. It's about midnight Sunday night. Oh yeah, yesterday is Wednesday's tomorrow. Tomorrow is Sunday's yesterday. What day would today be? Today would be Friday. Alright, we'll see you in the next video.